This is the Smart Buildings Academy podcast with Phil Zito, episode 218. Hey folks, welcome to the Smart Buildings Academy podcast, episode 218. And in this episode, we're going to do something a little different. So we have a free webinar coming up on Wednesday, September 16th at 12 p.m. Central Standard Time, and it is titled IAQ for Building Automation. Lately, our students have been asking us a lot of questions around indoor air quality, around demand control ventilation, around what to do with demand control ventilation and indoor air quality and COVID and all those kind of things. So what I'm going to do is, as part of the registration questions for the webinar, I asked people what questions they had about IAQ and what they would like to learn. For this episode, I'm going to be answering several of those questions and just kind of moving through those. I encourage you to go to podcast.smartbuildingsacademy.com/218, where you will find a link to register for this webinar. It's going to be really valuable. It's one of our most requested topics. And once again, it's completely free. So there's no reason why you shouldn't register for it. Even if you can't make it, you'll at least get the recording. And if you've ever been to any of our webinars in the past, they are not at all about selling a product to you like some webinars are. They are purely about educating you. So I believe you will find a lot of value. All right. So the first question we come upon is, how difficult is it to retrofit thermal displacement ventilation HVAC? And does TDV make sense for addressing airborne COVID? So when I first saw this, I was like, thermal displacement ventilation. I hadn't heard that term used before, but basically it's floor-based HVAC. So if you've heard of underfloor HVAC, where the theory is that you throw the air 6 feet up and you get a better mixing of the air from a occupant perspective. That's what that is. And so what they're saying is, how does this work with COVID? And that's a really good question. It comes from Mike, and it's one that I haven't heard people ask before, but it does bring up a very valid point. If we are so concerned about airborne transmission of viral contaminants, forget COVID, just anything in general, how does a floor-based HVAC system apply to that? Because, I mean, if you think about it, the whole premise of floor-based HVAC is that it will shoot the air about 6 feet up, which is going to provide really good thermal comfort. And because you're not really doing mixing, you're more so shooting the air up and then it is being exhausted out the ceiling, out the plenum, then what you're able to do is lower that discharge air temp. So that's kind of one of the arguments, is you use lower velocity air, you use lower temperature or higher temperature air rather, so you don't have to condition it down to 55 discharge. You typically will do like 65, and that air will provide better comfort for people. Now, that's all well and good, but then when we actually go and have to worry about viral contaminants, we're throwing air literally in people's faces. So how does this work, and how would you retrofit it? Well, the first thing I would look at is, what can I do that is going to mitigate viral load? And while there's studies, there's no proven science, but there's things like ionization, which should sterilize the airstream. There are things like UV, which will sterilize objects. And then there's filtration. Now, with underfloor, due to its low velocity, filtration becomes a little bit more of an issue. Because if you put MERV 13 HEPA filters in, you are going to create a pressure drop that quite possibly that floor system cannot overcome if it was not designed to overcome that pressure drop. So using filtration, while really good for normal discharge systems that are based in, on the roof and then piping into terminal units, using it for floor-based is going to have more of an effect. So just be cognizant of that. Ionization should sterilize the airstream according to the studies. I'm really trying to get someone from GPS on the podcast because they have kind of one of the leading ionization solutions to talk about that so we can have some real technical discussions. Haven't had any progress in getting them on the show yet, but hopefully I messaged their CEO on LinkedIn. Hopefully they should get back and say, hey, yeah, we're willing to have someone on the show. If any of you all know anyone at GPS, that you could say, hey, you should really get on the Smart Buildings Academy podcast so we can actually unpack this stuff, that'd be awesome. I'd love you to do that. Just feel free to LinkedIn message me or hit me up at my email, phil.zito@smartbuildingsacademy.com. So how difficult is it to retrofit? I mean, it really depends. If you're going for a filtration strategy, it's going to be quite difficult because you're going to have to upsize things. If you're just going for ionization, things like that, then not too terribly bad. Ionization and UV, you just got to have space to put them into the equipment. All right, so the next question comes from Todd, and it is, what is my opinion of OA control sequences found in ASHRAE's Guideline 36? So that's a really good question. So there's there's an OA strategy, and then there's a space pressurization trim and response strategy. And I feel that actually both of these need to be considered when we're talking about IAQ and when we're talking about viral load in a building. And this also goes to the Title 24 in California, which has somewhat similar controls strategies. But Guideline 36 was all about optimizing the utilization of equipment for energy consumption and demand-based usage. So if you look at trim and response, right, and you look at their demand control ventilation response sequences, they're all based on occupant load, they're based on load within the spaces, and they, right now, as best as I can tell, they conflict with the recommendations for viral mitigation strategies. What I mean by that is one of the recommendations is bringing in as much outdoor air as possible, and turning off demand control ventilation. So there goes that strategy kind of right out the door. And then the other strategy is increasing air changes and increasing flow rates. Well, if you're using a trim and response strategy, that can, in some cases, be impact. Now, here's the point. With trim and response, the nice thing you can do is you can raise. So most trim and response, they look at call for heating, call for cooling, and then they go and either trim the fan speed or they trim the discharge air temp. So you've got that aspect. So first, are you doing a flow-based trim and response, or are you doing a temperature and load-based trim and response? You've got to make that determination. And you can drive it off of two things, right? You can drive it off of call for heating, call for cooling, or you can drive it off of average box position, average valve position. There's many different ways you can iterate through trim and response sequencing. So when you're doing trim and response sequencing, you could essentially raise your thresholds, and by raising your thresholds, still get that optimal flow. And remember, it's not just about flow as well. It's about having that 40 to 60% humidity range, because what happens in that range of 40 to 60% is, as best as I understand it, not being a scientist, but based on the research I've done, is that the virus itself will start to dry out, the salt content will start to increase in the virus itself, and it will start to inactivate the virus. That's why you aim for 40 to 60%. We have a really good guide on IAQ that talks about all of this that I'm going to be sending out to all registrants of the webinar prior to Wednesday's webinar so people can read through it, and we're kind of along the same page. All right, let's continue along. Let's see what the next question I can ask. What are the required upgrades according to deal with COVID-19? So that's a good question that comes from Sergio. And so it really depends on what sequences you want to implement. So when you're looking at mitigation for viral load in a building and you're looking at increasing airflow strategies like that, first things first, you have to do a site audit. This is why I really feel that contractors and design engineers, if they are not positioning their businesses at doing site audits for their customers and really helping customers capture what they have in their buildings, they are missing out on a wonderful opportunity right now. Because like I've said many, many times on LinkedIn, I've said it on our live training calls, I've said it on the podcast, I really think we're going to be walking in to class action litigation in buildings because people are going to get sick when they reoccupy. And what do people do when something happens to them? They don't take ownership of it themselves. They just sue everyone. Yeah, I sound a little jaded on that. My parents are lawyers, so maybe so, but it just seems to happen. Anywho, not going to go any deeper into that rat's nest. But the reality is I can very much see people creating litigation because they got sick in buildings. And then that's going to affect the insurance agencies, which are going to start to require measurement and verification, but not the typical energy measurement and verification, more so reporting on IAQ data, which is going to drive acceptable KPIs, which then somehow, I'm not quite sure how this is going to happen, but it'll get put into some form of regulation where governmental agencies are requiring, and I'm just talking about the US right now, not Europe, but governmental agencies are requiring the reporting and measurement of specific IAQ KPIs, at which time all these customers of yours are going to be scrambling to figure out how do they retrofit their buildings. We're going to have a run on upsizing equipment. We're going to have a run on sensors. And we're really going to find ourselves in a massive retrofit market. So first thing I would do is help people figure out what they have in their buildings. Once we understand what they have in their buildings, though, then the upgrades, you got to think about it in layers, right? So you're going to have, and I'm just going to talk about building automation stuff real quick. I'm not going to really talk about HVAC. But from a building automation perspective, we have 4 layers, right? We have our sensor, our input-output layer. We have our controller layer and our field bus layer. We have our supervisory device layer, and then we have our server layer. So the server is where all the data logging is going to go. So what upgrades may you have to do there? You may have to get an analytics package. You may have to do more data storage. You may have to segment your databases, etc. Supervisory devices, you may have to up their capacity. You may have to upsize supervisory devices. You may have to upgrade supervisory devices in order to handle data flow and data analytics and data collection. Controllers, you may have to expand their I/O capacity. You may have to add the ability for programming changes in order to do sequencing of some of these IAQ strategies. And then from a sensing perspective, you're going to have to increase your sensor density so that you can go and properly deal with sensing humidity, sensing temperature, potentially sensing occupant loads, etc. Are there currently any guides for treating COVID by HVAC from ASHRAE or any other international orgs? Yes. So let me type it in while we talk so I can give you exactly what it is. But I believe you go to Technical Resources COVID ASHRAE. And if you type that in, Technical Resources COVID ASHRAE in Google, the first result that should come up will be like www.ashrae.org/technical-resources/resources. And if you click on that, it is a very exhaustive list of resources around recommendations. Now, I don't use the term guidelines. I use recommendations because no one's really put their neck out there yet to say these are the guidelines and these are the requirements. Everyone's pretty much still saying these are the recommendations. Is there any correlation between IAQ and COVID-19? Now, once again, I am not a scientist, so take what I say with it from the perspective of this is based on my reading and studying of the topic. But I'm not out there doing studies of IAQ and correlations to COVID. But from the studies I've read, there is a correlation between humidity and viral density. So as you have a specific humidity range, you decrease viral density. There are correlations between outdoor air, fresh airflow, and having a positively pressurized building to kind of flush air out and having a good exhaust strategy. There are correlations between purge modes. That being said, I am not a scientist, so do your own research. But that ASHRAE link I just talked about has a lot of data on that. So how do you convince a client or a stakeholder to adopt automation for HVAC as cost is normally the driver? So that comes from Nicholas. Good question on that. It depends on the customer and it depends on the building type. If this is a one-story commercial strip mall, you're probably not going to convince them. I'll just be real with you. The cost versus the asset value and operational cost is just not there. Now, if you move to a commercial office building, if you move to a school, if you move to hospitals, as you progress, I'm tempted to say they'll already have building automation systems, but my experience has shown me that while they have control systems, they don't necessarily have building automation systems. And I want to be clear on what that means. So a control system could be a pneumatic system, could be an electrical mechanical system. So, those old thermostats with a slider on them, and it causes, when the temperature is at the right value, causes a contact to close and engages a unit. So those systems, while they are control systems, they are not building automation systems. So they are not going to automate that control. They are not going to help you visualize that control. So as we move into these environments and IAQ being critical to the life safety of occupants, as well as the operation of these buildings, they will need that data. And so now it becomes less of a capital cost discussion. Now, granted, cost is always going to be a factor. That being said, it now becomes a risk equation. The closest I can equate this to is cybersecurity. So in cybersecurity, you analyze risks and threats, and you provide a value of that potential threat to business continuity. And then you say, okay, based on this threat, what is the likelihood of this threat occurring? And then you get a overall cost of that threat. And then based on the cost, you can then go and project what is a viable mitigation strategy. That's the same approach I would take. I would say, okay, for a school district, if you have an IAQ issue, what does that mean from a student attendance perspective, and how does that affect cash flow? Same with healthcare or commercial real estate. So I would go and this is the tough one, really, Nicholas. This really is, because there's a lot of data, but there's no real analysis on, and I wish someone would come up with this. Honestly, I'm not 100% sure how to even start approaching it. Of doing a cost analysis of saying, okay, this is the potential cost of occupants not being in your space. Like, would you say for a commercial real estate building, would you say tenant retention and lower lease rates because people don't feel safe in the building? But how do you quantify that? Once you figure out how to quantify that, then it's as simple as saying, okay, what is the impact that automation, visualization of IAQ data, and reporting of IAQ data can have upon that cost, and does it make sense? So that is what I would look at. That's how I would approach it. Excuse me. Teresa, I believe that is how you say your name. I've never seen it spelled that way. That's interesting. What are the indicators of poor indoor air quality? So there's some basic indicators. One of the first ones is CO2. So CO2 buildup, having high CO2s in the 1,200 parts per million or higher, tends to be an indicator of poor ventilation. VOCs, which are volatile compounds, that is also a potential indicator of indoor air quality. I know at a company I used to work with, they had a outdoor air intake that used to be fine, but they redid the building, and so now it was a loading dock, and whenever the cars would come to drop stuff off, the trucks, they would idle, and all that diesel exhaust would get sucked into the outdoor air intake. And so there were some people that were being served by that unit, and they were getting consistently sicker than other people in the building, and they were having issues with this, and they couldn't figure out why, until one day someone just was doing a maintenance, and they were doing a maintenance and the trucks were exhausting at the same time. They're like, man, what is that smell? And then they're like, oh my goodness, that's diesel exhaust. And they realized that this diesel exhaust was actually being sucked right into the outdoor air intake, which the outdoor air intake used to be fine, but now that the building had been repurposed, it was no longer fine. And so that is an indicator. So VOC and air quality. So it's really air quality. But then also I feel that something that is ignored, because so many folks focus on VOC and they focus on CO2. I feel that temperature and humidity is often ignored in air quality. While that does not directly affect, I guess you would say, the quality of the air, I feel it affects the quality of the tenant's experience. And so having temperature and humidity that are outside of ASHRAE 55's thermal comfort range, that's going to affect the evaporative effect. That's going to affect just comfort. And when people aren't comfortable, they are going to be affected in their work experience. Like my wife and I are constantly fighting about temperature, because I work in our basement. That's where I have our film studio. That's where I have our recording studio. And I turn the basement to 67 degrees because when I shut the doors on my office and I turn on all these lights, it gets extremely hot in the space because the space was not ventilated for that additional thermal load. So that is, in my opinion, a IAQ issue, although you could call it a thermal comfort issue. Alrighty, let's continue along. Are UV lights the best solution? And that comes from Patrick. Great question, Patrick. I recently wrote an article for Engineered Systems for this month, and I talked about, it may be next month's article, and I talk about the 3 strategies really for IAQ from a mitigation perspective. And those are the bipolar ionization, the UV, and the HEPA MERV13 filtration. Now, each one has their pros and cons. And so I don't think there is a best solution. I think there are solutions for situations that are a better fit than others. So when you're trying to sterilize an airstream, UV light, it's very difficult to sterilize airstreams because UV lights have a minimum exposure time in order to properly sterilize. So you will see them for spot sterilization. You will see them to sterilize specific coils or filters or spaces, etc. They do quite well in that. They don't do as well in sterilizing a moving airstream. That's where bipolar, I can never say this, the ionization solution comes into play. And the ionization solutions come into play in that I believe they negatively charge the particles, which cause them to starve of hydrogen, if I remember correctly. So they tend to work very well on airstreams and sterilizing airstreams. So they are a good solution for that. And then you have filtration. And filtration does really well. The problem with filtration is the pressure drop. So if you have not sized a system to accommodate that pressure drop, then you're going to have major issues with that. So it is a combined strategy. You can use UV lights, and I'm seeing UV lights in some ballasts. Manufacturers are releasing this. And so they will do a sterilization mode when the spaces are unoccupied, and the UV lights will sterilize the space. I'm also seeing ionization being used for airstream, and I'm seeing filtration being used for airstream. Filtration is an easy add. It's very easy to go pick up MERV13 filters and add them in if you have the excess flow capacity in your system. Most systems do not, and so you can't just go from MERV9 to 13. It's something that you have to accommodate that pressure drop. All right, I think we have time for maybe 2 more questions here. Let's take a look. How can we quantify fresh air exchange rates? No. What do I think about needlepoint ionization? I already covered that. Recommendations based on complexity of systems. Are certain BAS systems? This is a good one because I feel like it ties right back into what I believe we're going to be entering, which is a retrofit and not a capital market. I just don't see why people would be building buildings when we're not able to get them fully occupied right now. So Wayne asks, are certain building automation systems more amenable, meaning they're easier to implement IAQ strategies in than others? Are BAS systems of a certain age unlikely to support IAQ activities? Yes and no. So let's answer the yes, and then let's answer the no. So are certain systems more amenable to IAQ? Yes. I mean, if you have a building automation system that is newer, you should, as long as you have the programming tools, be able to implement strategies around IAQ. You may not have the sensor density to do the logging that you need, so you may not be able to do some of the humidity control. You may not have humidifiers and dehumidification sequences, but for most of them, you can go and make the code changes. Now, on some of the legacy systems that have application-specific controllers, and that's really what I would be looking for, is do the systems that I want to work with, are they free programmable or are they application-specific? There's some 1970s technology that is freely programmable. It's line code stuff, but I mean, you can program it. And there is some brand new stuff that is application specific and you can't program it. So that would be my first thing. Is it an application specific based field system or is it a freely programmable based field system? Then from there, I would ask, what do I want to do with IAQ? Do I simply want to implement a purge mode? Do I want to actually implement certain sequences that are going to require more data points? And that's really kind of the cutoff in my opinion. If you are looking at a system or a sequence rather, that's going to require more data points and more data collection and more data throughput, then you probably, if you have a very old legacy system, we're talking 2005 and earlier, you probably need to retrofit, at least at the field controller level, to be able to handle all that new I/O. Because let's be real, on most buildings, you are not building in excess capacity. My general rule of thumb is 10% excess capacity on a system. Now, some folks really want to cut it to the edge and they want no excess capacity. I like to have 10% I/O capacity for situations like this where I need to add a humidity sensor or something like that. So if it's an older system, it's most likely going to be more difficult to add additional I/O and to add data flow intensive sequences like analytics, M&V, etc. Other than that, though, most systems should be able to do it. Now, that's right now. I really firmly believe, and this is really important, Wayne, I really firmly believe we are going to enter and it's probably going to happen pretty soon, a time period where we are required to log IAQ data, report on IAQ data, and it becomes an important executive level KPI that people are monitoring. When that happens, yes, I think we will see a real need for legacy systems to be upgraded. I do want to say one thing real quick, is that you are coming to an end of life with the Niagara AX, which is one of the more popular building automation systems with a pretty large market share. As that end of life, I think that is going to open up a lot of retrofit opportunities, whether those are Niagara N4, those are some other system. I think that compounded with M&V requirements and IAQ KPI requirements that are going to be around the corner, I believe that will drive us into a retrofit market. So this question that you asked will become even more important. Alrighty, let me take a look at a couple more questions. How do we offset energy costs of increased outdoor air? Ooh, that is a difficult one, Patrick, and I'm going to take that because there are so many ways you could answer this, right? So how do we offset the energy costs of increased outdoor air? And I would even take that a step further, which is how do we offset the energy costs of increased ventilation rates? Because let's be real, not only are most of the sequences asking for increased outside airflow, they're also asking for increased air changes, they're asking for purge modes, etc. So this becomes a very valuable question. In some cases, let's be honest, we're not going to be able to offset the energy costs. If you're in Florida or you're in Louisiana and you're bringing in outdoor air, the recommendations by ASHRAE are to bring in as much outdoor air until you lose control of humidity and thermal comfort. Because they don't want you bringing in 90% relative humidity Gulf air that's, full of humidity and moisture, and it's just going to saturate your building and cause all these issues. If the building is all molded, you can't even work in it, then it really doesn't matter. So one of the strategies we can take is stepping away from generic schedules and moving to occupancy-based schedules. So the reality is, in a lot of buildings, we are not fully occupying them. So if we are only occupying one floor of a building, one of the strategies would be to only schedule that one floor. So by default, most chillers, if they have a VSD on them, if they have some form of regulating load, they are going to be able to stage down or at least load down to reduce energy consumption. So the chillers, the air handlers, etc., from a temperature control perspective, as we reduce the thermal load in a building, they should, by nature, reduce utility costs. Additionally, as we look at the energy consumption or the occupant saturation of a building, and we look at where the occupants are, we can then appropriately schedule systems. We can make our terminal units only be occupied in spaces where people are at, make our air handling units only occupied where they are serving spaces that have occupants. So this is going to be most likely common corridors and specific spaces. So that would be my first thing, would be to really, if you can, get very tight on controlling the actual occupancy of your building based on where occupants are at. That is probably the easiest way to reduce utility spend within a building. The second way is to be cognizant of your OA strategies. And so when you're doing outdoor air, for some folks, it may make sense to introduce a preconditioning system and have that preconditioning system precondition the air. Now, that will have some cost, right? Because you're going to have cost to go and remove humidity out of that airstream. However, if you can do that by removing air prior to bringing it in to the air handling system and taxing your central utility plant or whatever, then what you're able to do is maybe it's really going to be 50-50 whether that actually reduces utility spend or not, as I start to logically think about it. Whew, this is a tough one, Patrick. I feel, based on my experience doing a lot of sequencing in the past, really your best bet is just going to be occupancy-based scheduling and loading. Because as I thought more about preconditioning air, that's still going to introduce an additional utility consumption to your energy profile. So yeah, I really am just coming up with reducing or utilizing your systems based on occupancy. So if you can tell that certain spaces aren't occupied, then putting them in a standby mode and reducing the utilization of the non-occupied spaces. That would be my strategy. So, hey, folks, this was just I think we went through 7 questions, and I have about 70, 80 more. So I really encourage you, man, if you found these questions valuable and you found this episode to be insightful, man, you really should sign up for Wednesday's webinar. It's going to be really good. Like I said, it's completely free. and we're going to have a great conversation around IAQ. We're going to talk through what IAQ is. We're going to talk about IAQ control strategies. We're going to have a really good question and answer session. It's going to be pretty valuable, and we're going to just have a good time with the webinar. So with that being said, thanks so much for listening to today's episode. I encourage you all to go to podcast.smartbuildingsacademy.com/218. There you will find the transcript of today's episode, and you'll also find a link to the webinar. Thanks a ton for being here. I really look forward to seeing you in the webinar. And hey, if you have questions about any episode, please ask your questions. I love to answer questions. It makes life a lot easier. Honestly, this morning when I got up and I was like, man, I got to record a podcast, I was just like, man, what am I going to talk about? You know, when you get to that point where you've done 200 plus episodes, you're like, what do I talk about anymore? I mean, you're like, I guess I could look at what episodes were most popular and like redo those, but the questions you all ask, that makes my life personally as a content producer so much easier, because it really gives me questions I can answer. And I feel like, maybe you don't, but I feel like you and I are having a conversation, and, you know, we're sitting down at a table and we're talking and we're like, hey, Phil, what about this? And I'm like, well, it could be this, but maybe it's this. And, you know, giving you the real answer, not kind of the marketing fluffy answer. I'll tell you if I don't know something. I'll try to point you to the right resources. And overall, I feel like both of us will leave this much more informed on the topic. So, hey, thanks so much for being here. I look forward to talking to you, hopefully on Wednesday's webinar, if not in next week's episode. Thanks a ton, and you all have a great day. Take care. Great day.